I am Amar Singh EU under registration number EG 2020-3817. Hello everyone. Today I am going to explain the architecture of our Big Data project. Big Data project e-commerce clickstream project. This project is designed to process customer activity data from an e-commerce website. The main goal is to collect user behavior data, process it in real time, store it for future use and generate useful business report. The first component in the architecture is data simulator.py. So in here, this script generates sample JSON events. These events represent user activities such as clicking products, viewing categories, adding items to the cart and making purchases. These generated events are now sent to a Kafka topic called clickstream topic. Kafka is used because it is suitable for handling continuous streaming data. In a real e-commerce system, thousands of users may interact with the website at the same time, so Kafka helps manage that data flow efficiently. Next, the data is consumed by stream-processor.py. This script continuously reads data from the Kafka topic. It acts as the real-time processing layer of the system. From this stream processor, there are two main outputs. The first output is real-time aggregation. The system analyzes the live data and can generate a flash sale alert on the console. For example, if a product suddenly receives high interest, the system can detect that the trend and alert the business team. The second output is raw data storage. The incoming clickstream data is saved into a local data lake under data raw logs. This is important because raw data can reuse for later for detailed analysis, reporting or debugging. After data is stored, the batch processing part starts. This is handled by Apache Airflow using the file called e-commerce batch.py. Airflow works as a scheduler. In this project, it triggers the batch jobs daily. The first batch task is segment users.py. In here, this script analyzes user behavior and create customer segments. For example, user can be grouped as frequent buyers, casual users, or inactive users. The output save as user segmentation.csv. It also creates a text file called top5products.txt which shows the most popular product. The second batch task is conversation analytics.py. This script calculates category-wise conversion rate. It helps us understand which product categories successfully convert users into buyers. The result is saved as category conversation rates.csv. Overall, this architecture combines both real-time and batch processing. Real-time processing helps the business react quickly to current user behavior, while batch processing helps generate daily reports for decision making.
Hello everyone, I am D. Soisa RNC under the registration number of EG 2020-3886. I am going to take you through exactly how we implemented this Lambda architecture in code and then we will run a live simulation. As a quick recap, how our code maps to the architecture, we have our data simulator acting as the producer that feeds into our speed layer which is powered by PySpark streaming. Simultaneously, the data is dumped into our data lake for a batch layer which is orchestrated by Apache Airflow. So let me start with the data simulator part. Let's start with the data generation as I previously discussed. Since we don't have a real website, we wrote a Python simulator. It randomly generates user clickstream events like view or add to cart or purchase. We weighted the events so that the views happen 85% of the time, making it realistic. Every second, it pushes the JSON events directly into the Kafka topic. This is the data simulator.py. that is doing that job. Then let me go to the stream processor. Next is the real-time speed layer. This is our PySpark stream processor. It continuously consumes the data from Kafka. There are two critical things happened here. First, it dumps the raw JSON events into our local storage. This is how we feed the batch layer. Second, it performs real-time windowing. We set up a 10-minute sliding window that recalculates every 1 minute. We have a filter here looking for high interest, low conversion products. If a product gets more than 20 views but fewer than 2 purchases, we instantly triggers a flash sale notification because it is makes sense. Then let me go to the e-commerce batch DAG. Finally, we have the orchestration and batch layer. We used Apache Airflow to manage this. This DAG is scheduled to run daily. It executes two Python scripts in sequence. First is a segment users.py and then the conversion analytics.py. So let me go to the segment users.py quickly. So what we are doing here is gathering all raw JSON logs that the stream processors dumped into our data lake throughout the day. We use as pandas to combine them into one massive dataset. Then we analyze every single user's behavior. If a user ever had an event type of a purchase, we label them a buyer. If they only viewed or added items to their cart without buying, that is most important thing, without buying, we label them as a window shopper. It also counts up the top 5 viewed product across the entire day. Then let me go to the conversion analytics.py to describe what is that is doing. After that finishes, which means the segment users parts finishes, Airflow triggers the conversion analytics part. Here we are looking into the big picture. We group the historical data by product category. We calculate a critical business metric, the conversion rate. It does this by dividing a total number of purchases in a category by the total number of views. This tells the business which categories are actually driving sales versus just generating browser traffic. You can see how the calculations are happening in here. So let me start the demo. Before starting it, this is our docker compose.yaml file. You can see the so there is a zookeeper service, then there is a Kafka, then there is a Airflow, how we up that. So first I will see from the docker ps command, you can see all the services are now Kafka and Airflow is successfully running. So let me on this terminal you can see I will run the data simulator first. I will run the data simulator first. So you can see it rapid. So you can see now I run the data simulator and you can see it's rapidly generating user event and pushing them to the Kafka topic, and you can see it in here. Then let me go to the stream processor. So I already loaded that. So I can run this stream processor. So it actively consuming those events. First I need to uh, activate the virtual environment. Then I need to run stream processor. So actually it is actively consuming those events which was done by previously. And as the views accumulate, watch what happens when our threshold is met. While that real-time processing happens, the raw logs are being saved. Let's move to the batch layer. Here is our Airflow UI. Here is our Airflow UI. We are going to manually trigger our daily e-commerce batch DAG from here. You can see I am trigger the DAG. The DAG has successfully run our heavy analytics jobs. Let's look at the output. So as I explained, this is the raw logs that's saved by the JSON file, and you can see it is also currently also it's generating. As you can see, the batch layer has successfully processed the logs, and here is our CSV files. Uh, in also you can see in here the top 5 viewed product is generated. It has accurately segmented our users into the window shoppers versus buyers based on the entire session history. You can see the user segmentation part as well, how users are segmented into the window shopper versus buyers based on the entire session history. And here is our summary of the top 5 views of the products today, and this is the category conversion rates are also here being got recorded. So in conclusion, we successfully demonstrated the Lambda architecture. We proved we can provide an immediate low latency business responses like flash sales while also orchestrating deep historical batch analytics. Thank you very much.